To start this lesson on solving systems of equations by substitution, we're going to examine this idea. A board game allows players to trade game pieces of equal value. So the diagram shows two fair trades. You can take 3 cars and a $100 gold bar and trade it for a house. You could take 2 houses, a car, and a $100 gold bar and trade it for a hotel. Okay, and we know that the hotel is worth $2,400. How much is a car worth? Well, right now we know that the hotel costs the same amount, 2,400, but the houses and the cars could cost different amounts, and if one of them changes, the other one's going to change. So it makes it impossible to know. But watch this. We can say, okay, we know that this is the case, and we also know this. Let me do a screen grab here of the price of that hotel, and we can say a hotel is worth $2,400. Okay. Now, we know that a house is worth 3 cars and $100. There's 2 houses there, so let's replace those 2 houses with 2 groups of the thing that they're equal to, like this. Now what we've got the $2,400 hotel equal to is 7 cars and 3 bars of gold worth $100. So 7 cars plus $300 equals the $2,400. And when we solve this, you should know how to solve this. We will come down to 1 car equals $300. Okay, that was a substitution situation, and we're going to learn about how to do that mathematically right now. So, what do we do? This is what it's going to look like mathematically. What is the solution of the system? Use substitution. Check out what we know. We know that y is equal to 3x. Now, it says here that if one variable is already solved for, which this just says y equals. We know what y equals. Okay? Then we can use it nice and neatly for substitution. Wherever we see y, we put 3x in. So, take a look what this looks like. Because y equals 3x, you can substitute 3x for y, they're equal amounts, into this. So if you had x plus y equals negative 32, the other equation, okay, we can take y and replace it with 3x. Yep, now you just have x's. 4x is equal to negative 32, and you can find out what x is. Now we know that x is equal to the value negative 8. Once we know that, this original equation, or either one of these equations really, but this equation is no longer in 2 variables because x is not varying. It's now negative 8. So we plug in negative 8, and we calculate that y is equal to negative 24. That means we have the equation, or the solution rather, negative 8 for x, negative 24 for y. Now we're going to check it by plugging these values into each equation. You've learned this earlier in the year. You take y, you replace it with what y is equal to. You write 3x, and then where x is, you put parentheses, and you put what x is equal to. And when you do this, you find out that you get a true statement, negative 24 equals negative 24. You have to do it to both equations. So x plus y equals negative 32, so we substitute negative 8 for x, we substitute negative 24 for y, and when we solve that out, we get negative 32 is equal to negative 32, which is true, so it works out the solution is proven to be true. So try this got it problem. You will see here that we do have an equation solved for y, so it should be easy to substitute what y is equal to into where y is in the other equation. Try it now. We'll come back with the solution. Okay, so how do we solve this? Well, we're going to take one equation, and we're going to replace y with what y is equal to. And here we have it that y is equal to x minus 1. So I take this other equation where it says y equals 2x plus 7, and where y is, I replace the algebraic expression that is equivalent to y. And now I have an equation that's just in one variable, and those equations we can solve. So What do? I need to undo what's happening here. Okay, I'm going to get the x's all on the right side, so I subtract x from both sides, and I'm left with -1 equals these combined to be x plus 7. Okay, now since this is single x over here, I want to get this off this side by doing the inverse operation to both sides, subtract 7, and what I get is x is equal to -8. I know what the value of one of the variables is. Now, I take the other equation and I replace x. You can really use any equation, either one. You replace x with the value that you know it is now. Now this equation is just in one variable and we can solve it and we find out what y is. Now that we believe we know the value of both variables, we do a proof. And the way that the proof works is we take both equations and we replace the variables with their values to see if it works out to be a true statement. So since we have y is equal to -9, we put -9 in for y. Since we have x is equal to -8, we put replace x with -8. And then we simplify it out, and it does work. Remember, we have to do both equations because, as I said, you can be on one of the lines, but not on the other line. We're looking for the point of intersection where the solution is. It's just like if we were graphing, we could graph both of these and we'd get the same solution of -8 comma -9 for the solution where they cross. But we got to verify that by doing the second equation. So we check it here, and when we plug in y is equal to -9, x is equal to -8, we find it's true. So we've checked both equations with variables and it works out both times. So the solution is -8 comma -9. Sometimes though, we need to solve for one of the variables when we're using substitution because it's not like the last problem was where it just says y equals. So sometimes we need to rewrite the equation so that one of the variables is isolated. Let's take a look at what that looks like. Okay, so what's the solution to this system? Use substitution. Now, we see these two equations, and we see that this is just says plus y. That's down to a single positive y, okay? Neither equation is solved for one of the variables, but we need the solution, and so we're going to solve one of the equations for one of the variables, and the second one, it makes the most sense to isolate y because all we need to do is add 2x to both sides, and now it'll say y equals. So, step one, oops. Solve for one of the variables, and again, there's probably a note over here that says, yep, which should we solve for? If one of the variables has a coefficient of either 1 or -1, you can solve for that one most easily, okay? This has a coefficient of 1, so we solve for that, and we say, okay, add 2x to both sides, and we get it equal to, they rewrite it so it says 2x minus 3. You don't need to, but they're doing that, okay? So this is the equation. This is what y equals. So we take the next equation and we substitute y for that 2x minus 3. Okay, so we say this is the equation where y is, we put 2x minus 3. It says 3y, so you have to put the 3 out front, 3 times that amount. And now you have an equation that's in a single variable. Okay, and when you distribute that through, you get this. When you combine like terms, you get that. And when you divide both sides by 10, you get the decimal 2.3 if you're going to write it in a decimal. You could also have 2 and 3/10. Now we know what one of the variables is. And we're not yet done because we did not solve for the other variable yet. Okay, so we're going to substitute x with 2.3 in either one of the equations, and then we're going to solve out and see what it tells us for y. When you do that, you get -4.6 plus y equals -3, and adding that amount to both sides, you get y equals 1.6. So now we know what y is as well. Now, for the sake of time, you should do a proof for these equations. I'm going to skip this. I've showed you how to do that, and you should do that every time. But for the sake of time in this video, I'll move forward on to the next problem. Okay, what's the solution to this system? You're going to use substitution, and you might be able to guess from looking up here which variable might be the easiest one to solve for. And that's what they're going to ask here. Okay, give this a go, and we'll come back and check your answer. Okay, so what are we going to do first? First thing we're going to do here is we're going to solve this variable for x, that second equation for x, because it says x plus. So it makes it nice and easy to just move the 3y away. And you get -7 minus 3y. So that's what x is equal to in terms of y. We don't know what its actual value is, but written as a description with y as the variable, we know that's what x is equal to. So what do? Let me move this out of the way. Take the other equation. We need to use the second equation. We use the first equation here. Okay, so we're going to substitute this into the other equation. And that's necessary, otherwise it'll just won't work out, because what you're trying to do is combine the two equations. So wherever x is, you replace it with what x is equal to, and now you have an equation in one variable, and we're simplifying it down here until we get to this, right? -9y equals 43, dividing by -9, and then turning it into a mixed number, we get y equals -4 7/9. This is the first time that we have a value of a variable that we know the exact value. Up here, this is just in terms of y. This is an exact value, okay? So we need to do it one more time to find out what's the value of x. So when we do that, we say, okay, we're going to take one of the equations and replace y with the actual value we know that it is, and then we'll be left with just a variable x that we can now have an equation in one variable and we can solve it. Okay, and distributing that through, I got -12, and 3 times 7/9 is 21/9. So I have -12 and 21/9. Well, 9 goes into 21 twice, so I get 2 more groups, and I'm now down to -14. And that means 2 times 9 is 18, or 3/9 is left over, and 3/9 reduces to 1/3. Okay, now I'm going to add -14 and 1/3 to both sides, and we find out that x is equal to 7/3. You can see how if you're not good with fractions, you're going to run into a major problem with this type of problem. But I'm going to be moving forward with the assumption that you do know fractions, and if you don't, it's on you to learn them, because I've been impressing this on you for quite a while now. So we have two values for the variables. We've got x is 7 1/3, y is -4 7/9. So what do we do now? We do a proof. We say, okay, we're going to plug in both of those amounts into the equation. X is 7 1/3, y is -4 7/9. That's going to get multiplied by 3. So this stays 7 1/3. That becomes -12 and 21/9. Remember, we did that over here, and we found out that it was equal to -14 1/3. So if we have a -14 1/3 and we add 7 1/3 to it, that brings this back up to just 14, the third does, and then the 7 brings us up to -7. So we're at -7 equals -7. That checks out. We need to do proof on the other equation, and when we replace both variables with their values and simplify out, again, -24, and 6 times 7 is 42/9, plus 5 times 7 is 35, and 5 times 1/3 is 5/3. Now we turn them, change these improper fractions into mixed numbers. 9 goes into 42 4 times, that's 36. So this goes down by 4 because it's a negative. And 36 taken away from 42 is 6/9, which is 2/3. Okay, here we can get one group of 3 out of here to make that 36. We have 2/3. So now we've got a negative number. We're taking away this amount from this amount. And if we're taking away 2/3 from 2/3, that's going to be an even number. And if we're taking 28 away from 36, we get 8. Okay, you can see how the math is getting complicated. And if you're not proficient in this kind of math, then you're going to struggle. So anyway, that's the solution. They both worked out, so we know that we have the right answer. So what we get is this value in part A. Part B here says, in your first step, which variable did you solve for? What equation did you use to solve for it? We solved for x in this equation. That's what this says. Okay, Problem 3, what we're doing here is we're writing an equation first, okay? Snack bar sells 2 sizes of snack packs. A large snack pack is $5. A small pack is $3. And in one day, the snack bar sold 60 packs total and made $220 from it. How many small packs did the snack bar sell? What do we need to do here? The first thing we need to do is define the variables. We're going to say X will be equal to however many large $5 snack packs we bought or that were sold, and Y equals the number of small $3 snack packs. And now we have two equations because here's the deal. We can say the small ones plus the large ones we know equaled 60 because they sold 60 packs. So X, the number of large ones, plus Y, the number of small ones, has to equal the 60 that they sold. Okay? But if you multiply the total number of large ones by 5, you find out how much money they made from each one. Okay, so 5 times the number of large ones plus 3 times the number of small ones, because small are $3, equals the 220 that they made. Okay, both times X is the number of large packs. Number of large packs plus number of small packs has to equal 60. And if you say we got $5 for each of the large packs, you do 5 times that many, plus 3 for the small packs, so 3 times that many number of small packs should give us the total amount of money. Now, we rewrite this equation. In order to solve for Y, it's 60 minus X. And now we're going to substitute in to the other equation what Y is equal to. Y is equal to 60 minus X. Okay, and now you have an equation in one variable. You can simplify it down. After distributing here, you can combine like terms. And then you can subtract 180 from both sides, divide both sides by 2, and you get X equals 20. You know one of the variables. Because remember, this was just in terms of X, what Y was equal to. We actually need to find out the value of what Y is equal to. So what do we do now? We say, okay, we're going to take one of the equations, X plus Y equals 60. And since we know that X is equal to 20, we say 20 there, plus Y equals 60, subtracting 20 from both sides, we get Y equals 40. And now we know what Y is as well. Okay, so what we get then is a solution where, give me a second. 20 comma 40. And actually, let me go over this. Right here it says, what does the solution represent in the real world? Check what the variables stand for. Here, 20 comma 40 represents 20 large packs because X is the large packs, and 40 small packs because Y represents the number of small snack packs. Okay. So then you get the snack bar sold 40 small snack packs because you got to remember the question, how many small snack packs did they sell? Okay, here's your got it problem. You pay $22 to rent 6 video games. The store charges $4 for new games and $2 for older games. How many new games did you rent? You'll need to start by defining the variables. Let X equal whatever it stands for, and let Y equal whatever it stands for. And then you will write the equations that represent this situation, okay? And then find out what the variables are equal to. Good luck. This is a challenging one. Try it and then start the video back up and you will see your solution here. Okay, how are we going to do this? Well, let's define the variables first. And the way that I did it, I said let X equal the number of new games and let Y equal the number of old games. Remember, there's two things. You know how many games you got total. You got 6 games total. And so you can say X plus Y equals 6. The number of new games plus the number of old games equals 6. And what I did here is I just solved for X by subtracting Y from both sides. Now we know X is equal to 6 minus Y. Okay? How's the other way that we can write an equation from this? Well, we know the cost of each one. So we can say if the new games cost $4, then 4 times the number of new games will be how much you pay for the new games. And Y represents the old games, and you're paying $2 each. So 2 times however many old games you rented will be how much you paid for renting the old games. Okay? And that should equal the total $22 that you spent. Now, we've got this solved for X, and so we're going to replace X with what it's equal to in terms of Y, And now we have an equation in one variable that we can simplify. You distribute through, get this. You combine like terms, you get this. And then we have just the y's are on the left side. So let's get this 24 off by subtracting 24 from both sides. And now we've just got 2y equals -2. And you see that y equals -1 when we divide both sides by 2. I'm sorry, y equals 1. So what do we do now? We know one of the variables, it's y is equal to 1. The other variable is only in terms of y, right? Not the solution itself. So we take one of the equations, we replace y with 1, and we solve for x, and we find that x is equal to 5. Now we know that we've got 5 comma 1 as our solution, and we need to do a proof. So we write each equation and plug in the value of the variables, and when we solve it out, we find out that the first one, it works for the first one. Let's try for the second one. And we find that it does work in the second one. So we've got x equals 5 and y equals 1. What are they asking us? How many new games did we rent? Well, the new games was represented by x. We look at the value of x. X is equal to 5. So we rented 5 new games. Okay, so you might remember that there are two special cases. If we were graphing them, it would be that the lines were parallel, which means there's no solution, or that the lines were really just the same line twice, right? Right on top of each other, in which you get infinite solutions, okay? So if we get something like 2 equals 2, when we get to the end of it, we substitute one of the variables and the other one disappears too, and it just leaves us with like 2 equals 2, then we call that an identity. It means when it's true, there's infinite solutions, okay? But if you plug in one variable with what it's worth in terms of the other variable, and the second variable disappears as well, and you get something false, like 8 equals 2, then it is no solution. Okay, so that looks like this. Okay, in this particular equation, and by the way, here's what it says. There can be how many solutions? Well, you can have exactly one solution, like the ones we've been doing, or infinitely many, if it was two lines right on top of each other, essentially the same equation, or no solution if it is parallel lines. Okay, so let's do this first one. Okay, you take the equations, they already tell you what x is equal to. So when you substitute it in, you put in -2y plus 4 wherever you see x, and you simplify it out. Notice what happens here. When you distribute this through, you get -7y and 7y. You try and get rid of one of the variables, and the other one goes away as well at the same time. You're never able to solve for what one of the variables is, because when one goes away, the other simplifies out and goes away too, and you just get 14 equals 14. You didn't find the value of the variables, okay? Because there's an infinite number of right answers. 14 does equal 14, always. It always equals it. So whatever you plug in for x, you're going to get the right, whatever value of x and y you have from a point on the line, no matter where you are on the line, that x and that y will go together and solve it. Okay, so what about this one? Well, we have y is equal to 3x minus 11, and so we can substitute 3x minus 11 in here for y. And when you simplify this out, notice you try and get rid of the y term and just be left with x terms. And the x terms now actually all cancel out too. But what you get is a false statement. That's not true. That means there is no solution. Okay? And that's the idea with this. So let's try it as a got it problem. Okay, how many solutions does the system have with these two equations? Remember, you can get one solution, you can get infinite solutions, you can get no solutions, and you've got to understand what happens in each of those cases in order to tell you that's what it is. Okay, try this got it problem, and we'll check it after the break. Okay, so what are we going to do here? Well, on the left-hand side, I have it solved one way. I'm going to show you something. you can say, okay, well, we know that we can solve for, first get the y's all by themselves. And when we do that, we find that 3y is equal to 4 minus 2.5x. Now I'm going to show you something. I didn't divide by 3 and get it down to y equals. Why not? Because actually this equation, the other equation, I can actually write in terms of 3y, okay? It says 6y there. That's just two groups of 3y, and we know what 3y is equal to. So I didn't actually need to get it down to just y. I could say if I know what 3y equals and I have 3y in my problem, that's fine. I know that I'm allowed to put this wherever I see 3y. So I rewrite 6y as 2 times 3y, and then write that in there. And when I distribute it through, you see that I'm trying to get rid of the y terms by replacing it with the x expression, and x goes away too because we get negative 5x and positive 5x. So what do we get left over? 8 equals 8. And that's true. So that means that we have an infinite number of solutions. Okay? But I want to show you something else. Before you did all that substitution, you could also just examine the problem like this. You could say, okay, 2.5x plus 3y equals 4. If you multiplied both sides by 2, what you would get is 5x plus 6y equals 8, or rewriting it so the y's were first, you'd get 6y plus 5x equals 8. And what do you know? That's what that first equation was, okay? We took this equation and we multiplied everything by 2, and it turned into the exact same equation as the other one, which means it's the same line, which means they're right on top of each other and they touch at all points, and there's an infinite number of solutions. So another way to look at it. Okay, these lesson check problems will definitely tell you whether you know what you're doing or not. If you don't try to do these, it may be because you realize that you're struggling with or you're confused. If you're confused, the time to ask is not right before the test. The time to ask is right now. Sign up for office hours, come with a friend that also doesn't get it, and get an understanding of this, because we'll throw some problems at you that are not quite as complex as the ones we've been doing in this lesson, although you do need to understand all of that math, and you're expected to at this point. So I didn't give you the easiest ones. I just did what the book supplied us with, because you need to know how to do all of the problem types. But if you find these hard, if you're confused, watch the video twice, try these lesson check problems, and then come to enrichment if you need me. Okay? But try these, and I'll give you the answers in just a moment after the pause.